Hey everyone, and welcome back. Today we're diving into fusion power.
Fusion power.
Specifically, a company called Pacific Fusion.
Oh, yeah, I've heard of them.
Yeah, they're making some pretty bold claims,
Okay, like what?
saying they can get commercial fusion within the decade.
Wow.
And get this, the person leading it is Eric Lander.
Really?
Yeah, the geneticist.
Oh, wow, from the Human Genome Project?
Yeah, the Eric Lander.
That's pretty interesting to see him move into fusion.
Right. It really makes you wonder what he sees in it.
It does.
So let's start with, who is this guy? And why is he leading a fusion startup?
Well, you already said it. He's got an impressive background. Led the Human Genome Project, founded the Broad Institute, and advised presidents. The guy definitely likes a challenge.
He does. And I read that there was a report from Science for America that really got him interested in fusion.
Right, yeah.
So what was it about that report that really sparked his interest?
It seems like it highlighted all these recent breakthroughs in fusion research, suggesting that we might be closer to practical fusion energy than we thought.
Oh, so like it really is possible now.
Maybe, at least that's what the report said.
Wow. Okay, so he saw that and decided fusion was the next big thing.
Yeah, basically.
Okay, so before we go too far, can we just take a step back and for anyone listening who might not know, what even is fusion?
Sure.
And why has it been so hard to achieve?
Fusion, right. Okay, so you're basically fusing two lighter atoms, usually hydrogen isotopes, into a heavier one, like helium.
Okay.
This process releases a ton of energy.
Like a lot of energy.
A lot of T. It's like what happens in the sun.
Oh, wow.
The hard part is getting the same conditions here on Earth. It takes crazy high temperatures and pressure to force the atoms together and get them to fuse.
Okay, I see.
We're talking millions or even billions of degrees Celsius.
Whoa, no wonder it's been so difficult. So how is Pacific Fusion trying to solve this?
Well, they're doing something called pulsed magnetic fusion.
Pulsed magnetic fusion, okay. What is that?
Basically, they use super strong magnetic fields to squeeze tiny pellets of hydrogen fuel. They squeeze them until they get hot and dense enough for fusion.
Okay, so like a giant magnetic fist squeezing these pellets.
Yeah, pretty much. But here's the really interesting thing. Lander says all the big scientific problems with this method have already been solved.
Wait, really?
Yeah, he says it's an engineering challenge now.
So he's saying they know how to make fusion happen.
That's what he's saying.
Wow.
But saying it and doing it are two very different things. They still have to build a working prototype and then scale it up to a power plant that can actually be used.
And that's where things get really difficult, right?
Exactly.
So what are some of the biggest challenges they're facing right now?
Well, the timeline is a big one. They're aiming for a full-scale demo in the early 2030s.
Oh, wow, that's a ways off.
And commercial plants will come even later. That's a long time to keep investors interested and the money coming in.
Yeah, true. Plus, this is super expensive stuff to build, right?
Absolutely. Funding is a big hurdle, for sure.
Makes sense. And they aren't the only ones doing this, right? There are tons of other fusion startups all competing with them.
Yeah, lots of competition. Everyone's trying to get funding and saying they're close to a breakthrough.
Wow, so it's a race.
Yeah, a pretty high-stakes one. It'll be interesting to see who can deliver.
Definitely. So how is Pacific Fusion trying to stay ahead? What are they doing differently?
Well, one big thing is their focus on mass production. They're designing their power plants to use mass-produced, standardized parts.
Oh, interesting.
To bring costs down and make the technology more commercially viable.
So it's like instead of custom building every part, they're thinking about building a reactor that can be assembled on like an assembly line.
Yeah, exactly. Like building a car.
Interesting approach.
It's risky, but if it works, it could be huge.
Yeah, I see that. And I also read that they're using a lot of simulations in their development.
Right, yeah. They use computer models and simulations to test and refine their designs before actually building physical prototypes.
Oh, so they can work out a lot of the problems virtually.
Exactly. That could really speed things up.
Smart. Okay, so they're experimenting, but also using virtual testing. I want to hear more about their headquarters. What's it like?
From what I've read, they've got this office in Fremont, California.
Okay, Fremont.
Kind of a normal office park, you know?
Uh-huh.
But then you get to the back, and it's like a mad scientist's lab.
Uh-huh. Really?
Yeah, they have an 80-foot-long tank, and then these other tanks the size of giant hot tubs.
Wow.
Glowing electronics everywhere, wires and pipes all over the place.
That sounds awesome.
Yeah, they're building these modular units there, packed with capacitors and switches. That's what creates the huge electrical pulses they need for their fusion process.
Right, the pulses. So what exactly do the capacitors and switches do?
Well, the capacitors are like energy storage units. They build up a massive electrical charge. Then the switches release all that energy in one super short burst.
Oh, like a controlled lightning bolt.
Haha, kind of, yeah. And that's what compresses the fuel and triggers the fusion.
So what's the team like? Are they all feeling this mad scientist energy?
From everything I've read, yeah, they're super enthusiastic and dedicated. They really seem to believe in this mission.
It's contagious, right? That kind of energy.
It is.
It's hard to fake that.
Totally.
The articles quote the COO, Carrie Van Munch, as saying, "I would rather do this for the next decade than do 3 little things for the next chunks of years."
Wow.
So they're really committed.
Yeah, it sounds like it.
They're not just doing a job, they're trying to change the world.
Right.
Okay, so we've talked about the science, the challenges, but let's take a step back and think bigger picture for a sec. What happens if Pacific Fusion, or any of these companies, actually figures out commercial fusion?
Good question.
I mean, what would that mean for the world?
It would be revolutionary.
Really revolutionary.
Yeah, think about it. Abundant, clean, basically unlimited energy. It would change everything.
It would.
It's kind of hard to wrap your head around how big of a change that would be.
Yeah, that's what's so exciting about it.
But also a little scary.
Totally. I mean, the implications are huge.
Think about it. How we power our homes and cities, how we travel, manufacturing, maybe even space exploration. Everything would be different.
It's almost like a paradigm shift.
Exactly. And that's just the beginning.
Right. What about, like, the politics of it all?
Exactly. If we aren't reliant on fossil fuels anymore, that could completely change global power.
Wow. It's kind of mind-blowing to think about all the different ways this could play out. We could do a whole separate deep dive just on the effects of fusion power.
Totally. But for now, let's get back to Pacific Fusion.
Okay, yeah.
They're at the center of this story, pushing the limits of what's possible and giving us a glimpse of a future that used to seem impossible.
A future without energy scarcity. That's pretty amazing to think about. But we have to remember, it is still just a vision at this point.
Right.
They still have a ton of obstacles to overcome.
Absolutely.
That's what makes Pacific Fusion's story so interesting. They're taking a huge gamble, trying to solve one of humanity's biggest challenges. It's still up in the air whether they'll succeed.
Yeah,
But it's fascinating to watch them try.
totally agree.
Stick with us as we keep going with this deep dive. We'll be exploring their facility, the people driving this mission, and how their technology could change the world.
It's a big story for sure. We've been talking about fusion and what it could mean for the world. But let's get a little more specific. What about the impact on different industries?
That's a good question.
Yeah.
One that comes to mind right away is AI.
AI, yeah.
We know those big AI models use a ton of energy.
They do, yeah. To train and run them, it's a lot.
Right. So if fusion could offer cheap, abundant energy.
It could be huge for AI.
Right. Like take away a major limitation.
Exactly. Imagine if running those AI models barely cost anything.
Oh, yeah.
It could lead to so much innovation, new stuff we can't even imagine right now.
It's like taking the training wheels off a super fast bike.
Haha, I like that. And it's not just AI. Think about manufacturing.
Manufacturing.
They use a ton of fossil fuels right now. Fusion could be a clean alternative.
Oh, yeah, that's true. So much less pollution.
Exactly.
What about transportation?
Oh, yeah, good one. Electric cars are already pretty popular.
Right. But the range and charging time is still a problem.
Yep, batteries can only do so much.
But with fusion,
You could power entire transportation networks. Cars, trucks, trains, even planes maybe.
wow, that's amazing. Imagine traveling anywhere and never having to stop for gas or charging.
Right. It would completely change how we get around.
So many possibilities.
Yeah.
Okay, but we've been talking about all these great things.
Uh-huh.
Are there any downsides?
That's a good point.
Like things we need to think about carefully?
Yeah. Any new technology, especially one this big, is going to have challenges.
Right.
One concern is control. Who controls this technology if it becomes the main source of energy?
That's a good question. And who benefits from it?
Exactly. It's a big geopolitical issue.
So instead of fighting over oil, we could be fighting over fusion.
Potentially, yeah. That's why international cooperation is so important.
Yeah, we have to make sure fusion benefits everyone, not just a few countries.
Absolutely. We need to think about all this stuff early on.
So we need to be thinking about the ethics and politics along with the science.
Exactly. We need to be responsible about this technology.
Okay, back to Pacific Fusion for a minute. There's a lot of excitement around what they're doing.
There is, yeah.
What do you think it is about them that's got everyone so interested?
I think it's a few things. First, their timeline is super ambitious.
Yeah, 10 years is fast.
It's a real moonshot.
But people love a moonshot.
They do. It's exciting. And people want solutions to big problems.
Right. And they're not just saying they can make fusion work. They're saying they can make it affordable.
That's huge, yeah. Their focus on mass production, making the parts standard, that's different from what others are doing.
It is. And they realize that fusion has to be affordable to make a real difference.
Exactly. It needs to be practical. It needs to compete with fossil fuels.
Okay, let's talk a little more about their simulations. We touched on that before. How exactly are they using computer modeling?
So imagine trying to build this crazy, complicated machine.
Uh-huh.
Thousands of parts, all working together under these crazy conditions.
Okay, yeah.
You wouldn't just start building and hope for the best.
No way.
You'd want to model it all first. See how the parts work together, see what happens when things get really intense, figure out how to make it better.
Okay, so they basically have virtual fusion reactors on their computers.
Yeah, they're testing different designs.
And figuring out problems before they build anything.
Exactly. It's a virtual laboratory.
Now that's smart.
They can do thousands of experiments really quickly.
And save a ton of money.
Exactly. It lets them try new things and improve their designs fast.
It's like they're playing chess and thinking several moves ahead, trying to find solutions before the problems even happen.
Yeah, it's a really strategic way to do things.
They're using science, engineering, and computer power all at the same time.
Yep, it's cutting-edge stuff.
But even with all that, there's still a ton of risk involved.
Definitely. That's what makes this so interesting to follow. It's a huge gamble.
Right.
It could change the world, or it could be a huge failure.
I want to hear more about that risk. What are the biggest reasons to be skeptical? What could go wrong? Okay, so we've talked about all the good and bad things fusion could bring, the challenges, the risks, their strategy. But what about the people actually doing all of this?
Yeah, what about them?
What motivates them? How do they keep going when things get tough?
That's a great question. We talk about all this technology, but it's the people behind it that really matter.
Right. Their passion, their commitment, their grit.
Exactly. It's what makes or breaks a project like this.
And the articles really highlighted that.
They did.
They showed a team that's not just smart, but really dedicated.
Yeah. They really believe in this mission. It's not just a job for them.
Like that quote from the COO, Carrie von Miensch. I would rather do this for the next decade than do 3 little things for the next chunks of years.
It's powerful.
Yeah, it shows how much they care. And it's not just her, right?
Right.
The whole team seems to have this energy, this excitement.
They do. It's contagious. They're pushing each other, inspiring each other.
It's like they've created their own culture.
Yeah, a culture of ambition, of innovation.
It's no wonder they're attracting the best people.
Oh, yeah, and they need those people. Building a fusion power plant, that's one of the hardest things you can do.
I bet. So many different fields, so much expertise.
Physics, material science, computer engineering, it takes a village.
They've got an all-star team for sure.
And they're not just relying on the experienced folks. They're bringing in young scientists and engineers, too.
That's smart, training the next generation.
Yep, making sure the work continues.
But even with the best people, it's still uncertain.
It is.
I mean, fusion has been this dream for so long.
Yeah.
Is it really possible they'll pull it off where others haven't?
It's a huge question. It's high risk, high reward.
So let's talk about the reasons to be skeptical.
Yeah.
What could go wrong?
Well, like we talked about, the technical challenges are huge.
Yeah.
Creating a fusion reaction and keeping it going, it's so hard. It's like trying to, I don't know, trap a star in a bottle.
Uh-huh, yeah. And even if they get it to work in the lab.
Right, then they have to build a whole power plant.
That's a whole other level of difficulty.
It is. It has to be reliable. It has to be efficient. It has to run all the time.
So it's one thing to make fusion happen. It's another thing to make it practical and useful.
Yeah, exactly. And then there's the money.
Right. Can they even do this affordably?
That's the big question. Can they make fusion power cheap enough to compete with other energy sources?
That's where their mass production strategy comes in.
Yep.
It's risky, but if they can pull it off,
it could change everything.
So it's a lot of hope, but also some doubt. We're excited to see what happens.
Me too. It's a fascinating story. It shows what humans can do when they set their minds to something.
Trying to solve these huge problems.
And it makes you think, what else can we achieve?
That's a good point to leave our listeners on.
It is.
We've explored the science, the challenges, the possibilities, and the people working on it. But now we want to hear from you.
Yeah, what are your thoughts?
Are you inspired? Skeptical? Somewhere in between? What stood out to you?
And would you invest in a company like Pacific Fusion?
Knowing it's a long shot.
Because whether they succeed or not, their story is about pushing boundaries, it's about taking risks, it's about believing in a better future.
And that's something we can all be inspired by.
Absolutely.
So thanks for joining us on this deep dive.
Thanks for listening.
We hope you learned something, maybe even got a little inspired yourself.
Keep exploring.
Keep asking questions.
And keep diving deep.